I want to start today by pointing out something a little weird about your brain. Something you're doing right now, this very second, that you never actually learned how to do.
It's always the best place to start.
Yeah.
The things that are just hidden in plain sight.
So let's meet Jones. Jones is our hypothetical everyman for this deep dive. Just a regular guy, speaks English, has never taken a linguistics class in his life.
Right.
If I tell Jones, John is sleeping, he nods, he gets it. But if I say, John seems sleeping, Jones instantly recoils. It just sounds wrong.
It crashes, yeah. And it's not that the meaning isn't clear. I mean, you know what it's supposed to mean. But his brain just rejects the structure. It's a failure of form, not understanding.
Okay, so here's a harder one. And this is the specific riddle from our source material today. If I ask Jones, who do you want to see? He's fine. Wanna is just a contraction of want to. We all use it. But, and this is the kicker, if I ask, who do you want to see, John?
Yeah.
Suddenly, it's impossible.
Impossible. Right. I mean, who do you want to see, John? It may be a little awkward, but it's a possible sentence in some context. But who do you want to see, John? No, it doesn't work.
He knows he cannot contract want to into wanna in that specific sentence. But here's the thing. Nobody ever sat Jones down in kindergarten and taught him the invisible trace rule of contraction. I certainly don't remember that lesson.
And that is the mystery.
Yeah.
How does Jones know a rule that appears in no textbook? How does every child, just hearing fragments of messy conversation, end up with this incredibly specific, rigid system of rules in their head?
That question is the driving force behind the material we're covering today. It's Principles and Parameters, The Architecture of Universal Grammar by Noam Chomsky and Howard Lasnik.
Yeah.
And before anyone tunes out thinking we're about to discuss, sentence diagramming or when to use a semicolon, this is not that.
Not at all. This is basically reverse engineering the human mind. Chomsky and Lasnik, they're treating language not as a cultural artifact like a recipe you pass down, but as a biological object, a distinct component of the brain.
A mental organ.
A mental organ, exactly. And just like a liver has a specific function, this language faculty has a specific architecture. The source breaks it down into two states. You've got the initial state, that's the factory setting.
The hardware we're all born with.
That's what they call universal grammar, or UG. It's genetically determined, and it's uniform across the species. Doesn't matter if you're born in Tokyo, Toronto, or Timbuktu, you start with the same machinery.
Okay.
But then this faculty gets exposed to data, people talking around you, and it shifts. It stabilizes into what they call the steady state.
And that steady state is what we would just call knowing English or knowing Japanese.
It's the user-facing side of it, yes.
Yeah.
But that process, how you get from one to the other, that's what fascinates the authors.
The text uses a famous quote here from Wilhelm von Humboldt, "The infinite use of finite means." It sounds poetic, but they mean it mathematically, don't they?
They do. And this is where we have to make a really, really sharp distinction, or the rest of this won't make sense. We have to separate competence from performance.
Which feels a little counterintuitive. In the real world, we judge people on performance.
Right.
Are they articulate? Do they stutter? Do they use big words?
And for a scientist, that's just noise. Performance involves memory, attention, distractions, just losing your train of thought. If you're tired, your performance drops. Competence is different. Competence is the internal code. It's the generative procedure in your brain that can theoretically create an infinite list of sentences.
So competence is the software that's installed on the hard drive. Performance is what happens when you try to run that software on
On a buggy computer with way too many tabs open.
Right.
That's a perfect way to put it. The source actually notes that language isn't really designed for efficient use. Parsing, the act of listening and processing what someone says, is actually slow and really error-prone. We mishear things all the time. But the internal system, the competence, that's where the mathematical elegance is.
Which, okay, that leads to this other distinction in the text that, I'll be honest, it confused me at first. I-language versus E-language. When I think of English, I think of the dictionary, the library, the thing outside of me that we all share.
That is E-language, external language. And Chomsky and Lasnik basically just tossed that in the trash bin.
They're pretty dismissive. They call it a scientific artifact.
Because scientifically, E-language is just a collection of things people happen to have said. It's just a list.
Yeah.
Studying E-language is like studying a list of dinosaur footprints and thinking you understand the biology of the dinosaur. You're just collecting data points. You aren't explaining why the footprints look the way they do.
So the I-language is the dinosaur itself.
The I stands for three things. Internal, it's in your skull. Individual, it belongs to Jones, not to the community. And intentional with an S.
Okay, that's the tricky one. Intentional.
It just refers to the specific function or algorithm that generates the sentences. So think of it like this. You and I could have two different computer programs. My program calculates 21 times 2. Your program calculates 10 plus 32.
We both get 42.
Right. The output, the E language, is identical, but the internal code, the I language, is completely different. The scientist doesn't care about the 42. They care about the code. So when we say Jones speaks English, we're not talking about the words coming out of his mouth. We are talking about the specific state of his neural machinery.
Which brings us to, I think, the biggest problem in this field, the learning paradox. The text calls it this tension between descriptive adequacy and explanatory adequacy.
This is the conflict that broke early linguistics. So on one hand, you want to describe English perfectly. English is weird. It has complex rules. So early linguists, they wrote these massive, complicated rule books.
That's descriptive adequacy. You've got a rule for everything.
But here's the trap. If the rules are that complex, how on earth does a 2-year-old learn them? A toddler doesn't get a rule book. They just get messy speech, slang, interruptions. If your theory says English requires memorizing 10,000 roles, you fail explanatory adequacy. You can't explain how a child learns it.
But if you make the theory simple enough for a kid to learn, just copy what you hear, you can't describe the complexity because kids say things they have never heard before.
That was the deadlock. You either had a theory that described the language but couldn't be learned, or a theory that was learnable but couldn't describe the language.
So what's the solution?
The solution was the principles and parameters approach. This was the big revolution in the 80s.
P&P. Okay, so how does it solve the paradox?
By suggesting that we don't actually learn rules at all. Not in the way we learn history or chess. Instead, we're born with principles. These are invariant, hardwired. They never, ever change.
Okay, so the foundation is built in. But English is different from Japanese, so if the principles are hardwired, where does that difference come from?
The parameters. Think of parameters as a bank of binary switches, like a little fuse box in your brain. When a child is born, the switches are all open, they're not set yet. And as they hear language, they flip the switches to match the data they're hearing.
Can we walk through an example of a switch?
Sure. The classic one is the head direction parameter. So in every language, phrases have a head, the main word, and an object. In English, we are head first. The verb comes before the object. We say ate the apple. Ate is the head.
Right. I ate the apple. I don't say I the apple ate.
Unless you're Yoda. But in Japanese, that switch is set to head last. You effectively say apple ate. The object comes before the verb.
So the kid isn't analyzing grammar with a notepad. They're just listening for ate apple or apple ate. And then click, the switch gets flipped.
And this is the beautiful part. Once that switch is flipped, it applies to the entire language. You don't need 1,000 little rules about where to put the noun. You set one switch, and the whole complex system just configures itself. That's how you solve the paradox. A tiny bit of simple data triggers a massive complex system.
So there isn't a question rule or a passive voice rule. It's just the interaction of these deep principles with a few simple switch settings.
It makes the brain sound like a mixing board. You set the levels and the music comes out different, but the machine is the same. The rules we learned in school, those are just stylistic gloss. The real rules are these biological settings.
Let's look at the machine itself then. The text lays out this architecture of how a sentence is built. It feels like an assembly line.
It is an assembly line. It starts with the lexicon, your mental dictionary. You grab some word roots, like walking past 10.
When you hit D structure.
Deep structure. That's the base frame where you plug the words in, the raw material. Then things start to move. This is S structure. Words can migrate to different positions, like moving a question word to the front.
And then the assembly line splits. This was the part that really helped me visualize it. It branches into two different interface levels.
Right, because the system has to talk to the rest of the body. One path goes to PF phonetic form. That's the instruction manual for your mouth and your lungs. It's sound.
And the other path?
LF, logical form. And that's the instruction for your conceptual system, for meaning.
So one side creates the sound, the other creates the thought.
And this architecture is what explains that wanna puzzle we started with. This is where the trace comes in.
Okay, walk me through this again, slowly. Why can I say, who do you want to see, but not who do you want to see, John?
It's all about the assembly line movement. So when you think, who do you want to see? Deep down in your I language, the word who actually starts at the end. The base sentence is something like, you want to see who.
And then we drag who to the front to make it a question.
Yes, but, and this is the crucial part, when who moves, it leaves a little footprint. A trace. The text marks it with a little t. It's a silent, invisible placeholder in the structure.
So the real mental structure is, who do you want to see trace?
Exactly. The trace is at the very end. It's harmless. But now look at the bad sentence. Who do you want to see John? The underlying meaning is you want who to see John. The who is the subject of that second little clause.
Ah, okay. So who is starting in the middle of the thought? You want who to see John.
Precisely. Now move who to the front. Where's the trace left? It's left right there, sandwiched between want and to. The mental structure is, who do you want trace to see John?
And the trace acts like a wall.
It's a physical barrier. The rule for wanna is lazy. It just tries to squish want and to together because they're next to each other. But in this case, they aren't next to each other. That little ghost, that trace, is in the way. Want trace to.
That is incredible. So Jones can't say that sentence because there is a ghost in the machine, a structural placeholder that has no sound, but has the physical power to block a contraction.
It's maybe the strongest proof we have that syntax is a real biological structure and not just, a habit we pick up. If it were just habit, we'd probably say wanna there too because it's easier. But the brain says, no, there's an object here. You cannot merge.
It's weirdly comforting to know my brain has that level of integrity.
It creates a fascinating picture of what language actually is.
Speaking of biology, the text ends on a bit of a philosophical note about evolution. And usually, biology is, well, it's messy. The human spine is a disaster. Our knees are terrible. Evolution is a tinkerer. It just patches things together until they work well enough.
But Chomsky and Lasnik argue that the language faculty is different. They bring up this principle of full interpretation. They suggest the system is almost Galilean. It's surprisingly perfect and simple and economical.
No junk code.
No junk code. Everything in the final representation has to be interpretable by either sound or meaning. If a symbol doesn't do anything, the system just deletes it. It's an optimal system.
But wait a second. Language is messy. We have irregular verbs. We have go and went. We have idioms that make no sense, like kick the bucket.
And that's why they distinguish between the core and the periphery. The core, the universal grammar, that assembly line we talked about, that's the perfect crystal. The periphery is just the junk drawer.
So John seems sleeping is bad because it violates the perfect core, but went instead of goed.
That's just historical noise, an accident of history. The scientist studies the core. The periphery is just stuff you have to memorize. It's like the difference between studying gravity, which is the core, and studying why one specific leaf fell in one specific spot, which is the periphery.
So stepping back for a second, we started with Jones being unable to say a sentence. We've ended up realizing that Jones is operating a biological supercomputer.
We moved from looking at language as this big list of sentences, the E language, to seeing it as an internal organ with a set of switches, the principles and parameters.
The big takeaway for me is just redefining what learning even means here. We didn't learn language the way we learned state capitals or how to ride a bike. We grew it.
Just like a bird grows a wing. The environment sets the parameters, like soil determines how a plant grows, or nutrition determines how tall you get. But the seed, the universal grammar, it's there from the start.
It really democratizes intelligence in a way. The machinery in Jones's head is just as sophisticated as the machinery in Shakespeare's. The internal code is the same.
It is. The difference is just performance.
Now, there's one final thought from the text that I want to leave everyone with. It's about that parsing issue we touched on earlier.
Right. The efficiency paradox.
The text admits that while the internal system is perfect and elegant, parsing, actually listening and talking, is often slow and error-prone. It's not designed for efficient use.
Which raises this massive evolutionary question. If language is this perfect, elegant internal system, but it's actually kind of terrible at the practical job of communication,
Right.
What was it evolved for?
Right. Is it actually a tool for talking? Or did we evolve this infinite recursive system for thinking, and we just happen to use it to talk to each other?
It's very possible we're looking at a tool designed for inner thought, for structuring the world inside our own heads that we've simply hacked for conversation.
A supercomputer for thinking that we forced into a chat room. Something to mull over the next time you can't find the right words. Thanks for the deep dive.
My pleasure.